Okay, now that we figured out how the web compass works and how we can connect everything without having an extra cable, I'm moving to the next project. I have here parts that have been 3D printed. I don't have a 3D printer, but thanks to our friends that I know, I contact another person, and thank you, Liam, if you're listening to this. Thanks a lot for 3D printing the parts. Uh, these parts are, some of them will be the one used for the plug for the headphones, cockpit, captain, and first officer. I have here the four switches. Well, actually, the knob that goes for the map and chart uh, light panel. We have here all the 3D printed parts needed for the two map lights. This will be the one that goes on the top, and you can rotate and check. Parts the same. This is also needed for the ground lights. That is those lights that you can rotate. It becomes red and then white again, and it goes towards the behind each pilot. I have some other parts that will be used for USB. There is a USB plug that will go here, and I decided to put it there, so at least each pilot will have at least two USB connector if it's needed. I don't remember this one here. Now, the reason why the color is this is made with ABS, which is a very strong material, very good, very nice finishing. I need to print them with the REL 7011, which is the Boeing color. The reason why it's yellow, because the person only had the yellow colors. That's why I need to print it. To paint, sorry. After there's gonna be paint, give him probably 2 coats of paint, and then I can start building this together. So all the holes has been made already. All I need to do is basically find the nuts and connect everything, so this one can be work accordingly. I apply 1 coat of paint, and the result is already satisfied. Of course, I didn't have to paint everything, because this part will be inside the cockpit, so I don't really care if it was painted or not. So I'm trying to save some paint. What's important is the outside surface, which is the one that you actually see from the cockpit. So 1 coat of paint is actually pretty good. I don't have to do anymore. But I discovered I made a mistake. The ground lights parts I paint through the RAL 7011 paint, which is the Boeing 737 NG color paint usually, but these are actually black. I saw the picture on the cockpits and they're actually black, so I need to go back to the drawing board, repaint this with the black color. And the same goes for this that goes on top, and particularly for the ground lights, something that will go here is the potentiometer part, and this one will be paint red. This is red while the rest will be black. So I'm waiting for some small spray red and black coming through. Until then, there is not much I can do with this, but I can do some other stuff. Let's have a look what I can do. We are back upstairs for the next project. The next project is making the CB lights. The CB lights are located behind the first officer and the captain seats, and what they do is to shine lights to the CB panels behind the pilots, of course. Now this was already prefabricated and came together with my cockpit shelf from FPC, Flyby Cockpit. It's 2 parts. So one is obviously the base, and the other one is the section where the lights will be put. It's empty, so we have to create something. Now my idea is to have 2 LED, very bright, simple LED light, white, super bright, and 2 because I think one will not provide enough light. So these are both 12 volts each, so I can connect it together to 12 volts, and they're already dimmable because we tested before. And I will put something like a piece of wood where I have the two LED with LED case encapsulated. That one will go inside here, so the two LED will be inside stable, they will not go anywhere. And to cover that, I create a simple piece of acrylic. I cut it into shape, and this one will be put inside. It doesn't need any screw or any glue because I cut in such a way that you need to push a little bit to fit, and it doesn't go anywhere. So this one will create the effect of the CB light that I need. I will go start the first one and then move into the second one, because in total we need two. So I create these little things here. Just want to show. It's a little bit of compressed cardboard, very solid, with two LED. I need to push them a little bit inside, and then they're obviously block from the rear. So this one, all I have to do is to put into here and basically, I mean, you could use also cob lights. I think cob LED, they sell some, they are already rectangular. However, the one I found, they were too big for this shape here, so that's why I come up with this. So let me put this inside, nice and easy, and then hopefully I can show you the real fun result. So I have to go back to the drawing board. There was something not working. I could not manage to put the glass inside the LED were pushing against, and that's because the limited amount of space. So I check who was the problem, and all I can say is this is the LED case. The one that's not threaded, that's the part that's giving problem. At the moment I want to get rid of it, so I'm going to sew this off, sew the other one off, go back to the drawing board and see if removing those probably 3-4 millimeter of space allow me to close correctly the LED lights and the glass. Alright, so my plan works very good. It worked. I removed the excess, and now everything is inside. It doesn't look very good. I'm thinking later on to perhaps paint the inside with some sort of refracted color, something to give a little bit more shiny. However, this is gonna be way below, so you're not gonna see it right in front of it, and it's just to give the power, I mean the lights for the CB lights. Okay, so I start the first one. I'm gonna test it now, and perhaps we can do then the second one, and then this project is done. So let's see if it works. Now the things about this is that the LED have the different color opposite. So the black is actually the positive and the white is the negative. Just remember that, because if you try to do inverse, and you of course will try to give more voltage because you think it's not working, you can burn the LED. So let's see how this one works. Let's give. So this one simulates my map lights panel. Give a little bit. So at 2 volts they already start working, and then we got 5 volts, 7 volts, all the way to 12 volts, pretty much. Yeah. Very happy with the result. They definitely shine a lot of lights. At the moment you have a lot of sunlight here, so it's difficult to see it, but very happy. And they're also dimmable, which exactly what you will have in your CB lights on the forward. Just a second, I want to make sure that. So very happy with the result. Everything works fine. This is exactly how it's gonna work. They're also dimmable because this will be connected to your CB lights on top of the front overhead. There is the brightness and then there is the CB lights. I'm gonna create a second one and then I'm gonna stop for an espresso break. The second one is also done. Very pleased with the result. So these two CB lights are now ready to be installed. All I have to do is to extend the wires so I can then connect all these two together with the front overhead CB lights potentiometer. Let's go to the next project. The next project is looking at the dome lights. The dome lights are the one that you see attached to the CB panels behind the pilots. So we have one for the behind the captain and the other one behind the first officer. In reality, the first officer doesn't have to have this. I believe on the CB panel there is only this attached directly. But for the captain we have the full size here. I managed to find this directly on eBay. I think there was somebody that was 3D printing this and I purchased directly from him. Now I was trying to do it myself. However, as I said before, I do not have the 3D printer, although I have a friend of mine that can 3D print this, but I struggle to find the dome. There are some video on YouTube showing that the dome could be simple. The top of a Philips light that you can just unscrew and use as a dome. I couldn't find the lights anywhere, neither eBay or Amazon or any supermarket here. I found something that can resemble the dome, but it was not as good as this. I mean, this is 8 centimeter in diameter, and that's exactly what the real dome lights is. So I thought it's already well painted, it's already well done. Yeah, I purchased this. Now these are already have the resistor for the cob LED inside, so you can apply the 12 volts directly. So there will be 12 volts here and 12 volts here, all controlled by the dome light. Although the two lights can actually be reducing voltage, so you see the brightness goes down and going down and go up. The dome light doesn't have a simple potentiometer. It's actually a 3 position and it's off, dim or bright. Now I want to use the bright light at 12 volts exactly to have these two giving me the full brightest light, but then for the dim light it was a little bit of calculation that I needed to do, and I'll show you exactly what I come up with. I like to show you my calculation for the resistor that I need in order to simulate the dim for the dome lights. So the entrance will be 12 volts because the lights work at 12 volts, and we have the switch here that I symbolize with 3 contacts. One will be off, so nothing is connected, everything will be turned off. When I switch to bright, the 12 volts will go directly into the 2 LED providing 12 volts each and out, and therefore we will have the brightest lights. And when that happen, the current they will be drawn by the two dome lights will be 81 milliampere. Now how do I know that? Usually if you have the data sheets of the 2 LED, you can see the characteristic, the typical characteristic current and voltage, and usually is this way, so you can see exactly the current compared to the voltage. But I didn't have that because the two LED are inside the dome lights. I didn't want to disassemble. I don't know what LEDs were used, so I used the generator, power generator, to calculate to see exactly the current that was drawing when applied 12 volts. So we have 81 milliampere, so I stick with that. I also reduce the voltage up to 10.5 volts, and that gives me 10.2, 10.5, and that gives me a very good dim light. If you go below 10.5 or 10.2, I believe it was almost turned off. So I stick to 10.5 as my initial voltage that I need for the dim. So how do I get instead of 12 to 10.5? Basically, when I swap from bright to dim, the 12 volts will pass through a resistor, which will have a voltage drop, and the voltage drop will be obviously 12 minus 10.5, which should be 1.5. So calculating the voltage drop, we have that the resistor will be the V drop divided the current, and so we have 18.5 ohm. Now I don't have 18.5 ohm. I have the closest I have, it's either 22 or 15, so I decided to go for 15 plus or minus 1%. So this will be a little bit more or less with the percentage, but the reason why I decided to go 15 and not 22, because I prefer to have less resistor, so a little bit more voltage going through, and therefore less voltage drop. So we have, instead of having risking of turn off the lights, we'll have a little bit more. So 15, it's okay. Now with the resistor 15, I calculate that in total the voltage drop will not be 1.5 but will be 1.2 as I predicted. So instead of having 10.5, the dim will provide 10.8 volts, which is still acceptable. Then I also calculate the power for the resistor, voltage drop across the resistor times the current, so it gives me about 97 milliwatts. Therefore the smallest version that I have 50 ohm, a quarter of watt, which is more than enough to cover this power. So this is a typical simple resistor, nothing fancy. So by putting the resistor between in parallel between the dim and the bright, you absolutely nail the circuit. You make a very simple 12 volts going through. When it goes bright, obviously the current will go through the less resistant paths and it will not go through back. So this is also will be off anyway, so it will go 12 volts. When you go to dim, it will pass through resistor, voltage drop goes here, and this one will have less power to turn on, and all works. So that's the resistor I need to put across the two. To give you an idea of what it looks like when we apply 12 volts bright or 10.2 volts, which is the one I calculated for dim, I now set up this together with the power generator, and I'm gonna apply voltage. First we will go to the 10.2, so we see exactly how it looks like. We are pretty much 10 volts now. It starts, so 10. Okay, that's pretty much 10.2 volts. We are actually 10.23, but pretty much we are there. Now let's put this to 12 volts and see what the difference is. That's 12 volts. You can see obviously the difference, and imagine there will be two of these. So when you are in bright position, the two will illuminate the full cockpit. When you are in dim position, they will still illuminate but not as bright as much. So I'm very happy with the voltage that I choose. I have the resistor. All I need to do is to open now the overhead, locate the switch and solder the resistor, and also solder two wires which will provide the connection to these lights, and also to the 12 volts power supply they need to connect to the overall overhead. I have here the Sysmo solution after overhead, and the switch I'm interested is this one. It's now upside down, but it's dome, white, dim, off and bright. So I open the panel, and I need to pay attention because I don't want to break anything. And obviously we have the this is the board for the switch. I can see the switch is here, and I can see that the three contact of the switch is 1, 2, and 3. So we have probably the middle is the off one, and then we have the other two switch. I need to position. I need to understand which one is it. So I'm gonna do some tests with my multimeter and see which one is connect when I position the switch one side or the other one, and then all I need to do is to get the resistor and apply the resistor in parallel to the 2 points where it's between the bright and the dome and the dim, sorry, dim dome. Okay, so I'm going to work on that. Once the resistor is applied, I need to connect also some wiring, and the wiring are the one needed to connect the dome light. So the wire will be connected there, and I'm thinking to use perhaps the hole that's already been made for the ventilation system. There are a couple of holes that I can use. The wires are very small, so they can pass through, so I don't have to do any extra hole. Yeah, let's get to work. I just finished with everything I had to do. So I put the resistor between. It's not a perfect job, but I will do. And obviously I have my negative and my positive wire coming out, so that will be the one where I connect the lights. So everything works fine. Now there was another little problem that I have to sort it out, on top of obviously calculating the resistor and everything else. But this little board here with the switch actually works at 5 volts. In fact, the 12 volts arrive here, and then is step down to 5 volts, and everything else works at 5 volts. But for specific for the switch, I need a 12 volts. So what I have to do, luckily at the website Sismo Solution, they have some data sheets for each of the module, and if you go to the dome switch light data sheets, you can see the pin out of the connector, and from here you can understand that the pin 1, 2 are the one providing the voltage for the switch, and the pin 10 is the ground. So what I had to do, actually remove the connector and break, physically break the pin, so when the connector is put, there is no connection. The switch was completely disconnected from the rest of the circuitry, and so I can now I managed to provide the 12 volts directly with the resistor that's giving me output. I already tested on the with the lights, but what I like to do is to close everything and then show to you how it looks like. Welcome back. Everything has been mounted now, nice and done, connected to the power. Obviously it's not connected to Proxima, so it's not configured, but this is just to show you how it looks like when I apply the dome white light. So this will be behind the pilots, and what we have off position, it's off, then dim position we will have a dim light, and then bright we will have bright light for both of them. And we can see the bright light we are receiving 12 volts, exactly what I wanted for this cob light, and about 10.4, 10.5 volts dim. Very satisfied. Let's go to the next project.